Now, in this module, let us learn few things about acceleration due to gravity. To understand that, let us first learn what is free fall. The falling of a body. Body means any object from a height towards the earth's surface under the gravitational force of the earth with no any other force acting on it is called as free fall. In case of a free fall, no change of direction take place. But if you have observed, velocity of a falling object keeps on increasing continuously as the object approaches the earth. Since the velocity of a falling object increases, this motion is termed as accelerated motion, and this acceleration is caused due to force of gravity. You must have observed this. Many a times you play a game of throwing the ball upwards and catching it, right? So when the ball comes down, if you have observed, its velocity keeps on increasing as it comes down, right? But its direction of motion remains unchanged, right? This motion is called as accelerated motion, and the acceleration is caused due to gravitational force of the earth. That's why it is denoted by small letter g. Otherwise you people know acceleration is denoted by letter small a. But since this acceleration is caused due to gravitational force, it is denoted as small g. We have already learned about capital G, which is called as constant of gravitation. Don't get confused between this capital G and small g. Okay, so we will know few things more about this small g now. Now let us derive the formula to find out value of acceleration due to gravity. Let us consider an object falls freely towards the earth's surface. The mass of this object is small m and acceleration caused due to force of gravity is small g. Look at this diagram. The same thing is shown here. This is the small object and that object falls towards the earth's surface. This is earth. Okay. Mass of the earth is capital M and mass of this small object is denoted by small m, and acceleration caused due to gravity is small g. So all of you know F is equal to ma, but this acceleration is caused due to gravitational force. So instead of writing a, we have written g here. So F is equal to mg. This is our first equation. Now, according to universal law of gravitation, how to find out value of force of gravity? You people know that also, right? So F is equal to gmm upon r square. All of you know this capital G is nothing but this is the constant of gravitation, universal constant of gravitation, right? Capital M means mass of a big object. Here in this case mass big object means earth, right? So mass of the earth is capital M. Small m means mass of a object which is falling towards the earth's surface, right? And r is nothing but the radius of the earth. Why have we considered only radius of the earth? Now have a look at this diagram. Basically all of you know what is universal law of gravitation. There exists a force of attraction between any two objects which is directly proportional to product of their masses and is inversely proportional to square of distance between their centers. Now see, here the object is not very far away from the earth's surface. We have assumed that. Object is falling towards the earth's surface is close by, not very far away. So the distance from the earth's surface to this object, this distance from the earth's surface to the object is negligible as compared to this radius of the earth. Do you know what is radius of the earth? It is 6.4 into 10 raised to 6 meters. It is quite huge, right? So in front of this big number 6.4 into 10 raised to 6 meters, this distance of the object from the earth's surface is nothing. So we have ignored the distance of the object from the earth's surface, and that's why we have just considered radius of the earth to be the distance between the centers of the two objects. Okay, so F is equal to gmm upon r square. Now let us equate these two equations, equation number 1 and equation number 2. So what we will get? Mg is equal to gmm upon r square. What is same here to the left hand side and right hand side? Mass of the object, right? So we will eliminate that. So what remains behind? Small g is equal to gm upon r square, and this is the formula with which you can find out acceleration due to gravity. Now let us understand the significance of the terms involved here. So what is capital G? It is nothing but constant of gravitation, and its value is really constant, truly constant in the entire universe. And what is that value? 6.67 into 10 raised to minus 11 units. Then capital M, that is the mass of the earth. Okay, its value is 6 into 10 raised to 24 kgs. And what is this R? R is nothing but radius of the earth. Its value I have already told you, right? Okay, so if you have noticed in this formula to calculate acceleration due to gravity, do you see the presence of mass of object? No, right? So this acceleration depends on mass m and radius r of the earth. And so acceleration due to gravity at any given point on the earth's surface is same for all the objects, because while calculating acceleration due to gravity in this formula you cannot see, or we haven't considered mass of the falling object, right? So it is same for all the objects, whether it is heavy or light object of the same size, right? But this value of g, small g, means acceleration due to gravity, keeps on changing from place to place. We will discuss why and how in our next module.